everyone. My name is Murat. I work for Extend, and in one line, what Extend does is Apple Care for anything you may buy online. So lots of extended warranties. I'm also a Cypress ambassador, and I am flattered to be joining this team in this presentation. All these people are my idols, people I follow, and I use their tools all day at work. So I wanted to compare Cypress Component Testing to React Testing Library, and that's our stack. I'm sure a lot of the audience is that way. It started as a blog post that has a link over here, which you'll have access to later. And I wanted this presentation to be kind of a cheat sheet for people later. And here are the core points that I'm going to try to make. We'll go through a few examples of Cypress Component Testing versus React Testing Library. We'll compare the low-level spying and mocking capabilities. We'll compare the network spying and mocking capabilities. At the end, we'll have a demo of the developer experience. So at Extend, we've been using component testing for about 6 months. We've been using Cypress for 1.5 years. So you can see this snapshot on January 1st versus about now. We are piloting this application. Outside of this, we also are using Cypress Component Testing in the component testing library. So that's where it started, and then it got adopted here. So on January 1st, and there's a strong preference towards using Cypress Component Test. A lot of growth there. People are trying to cover component things in component testing versus in E2E, and they use E2E only when they really, really need it. So we have some experience in this space, and we are migrating from Enzyme to SciCT, and there's also RTL in the mix in there. So I thought this would be a good comparison of all. So some of the examples are from my book, Cypress Component Test-Driven Design, which you'll see the link here. In that book, there are more than a few dozen examples of SciCT versus RTL in every section. So I picked 3 of them, but first I want to start with the wrapper hell you may run into in the React component. So here are some popular wrappers like suspense and error boundary. You may find it everywhere in your applications, query client and whatnot. So in the Cypress component test, you have to mount the component the same way it's being used in your application. So you may run into these wrap components in all of the code bases that abstract away these complexities about your application. And at Extend, we have 3 of these, and we use them everywhere, and that's enough for us. What that looks like is a test that is mounting the component like this versus I'm mounting the heroes component here, but it has to be wrapped in many things for it to render correctly. Instead, we can use this custom mount and abstract away some of the things that we don't have to pay attention to. But this is not a new idea, right? As Cypress Component Testing Committee, we are growing in the shoulders of giants. And a lot of these ideas we can borrow from React Testing Library. This is the same exact code on the React side of a custom render. It's the same thing. Like we are wrapping the child with all the other wrappers, and we're just mounting it. So the first example is the simple component, header bar component. And we'll take a deeper look at this later, but this is just 2 links going to React.js, and the other one is going to the base application. It's just checking the spans in there. Here is the SciCT on the right side and React Testing Library Test on the left side. The way we mount the component is very similar, right? It's almost exactly the same. Cypress has a chain syntax. Many of you are familiar with left to right flow, getting an entity and chaining with should and similar. On the React Testing Library side, it's right to left variable assignment. After that, we make assertions on the variable. We have a similar within API between Cypress and RTL. And the rest of the test just is JavaScript, right? You're just iterating through the array, checking some text, the same way you're doing that in RTL. So it's the same test, different APIs doing the same thing. Here's another component. This is just a text field. So we are typing into it if it's readable, writable, and sometimes it's readable only, and you can't type into it. Now in this test, the only difference I want to point out is being able to stub out a property and just assert the number of calls that we're making. So we're just typing into it some value, and we're just making sure it's being called the amount of times that is as long as this value. Right? And on the other side, the equivalent of size stub is just FN. We have to make it a variable assignment, use it as a prop, and then make assertions on that variable. So you'll see this variable assignments and making assertions on that assignment very often in RTL. The rest of the test translates pretty well one by one. So we are also using Cypress test library here just to make the comparison even more closer. But pretty much it's the same exact test again, but it's just a minor difference. Here's another one. So this is navigating between heroes, villains, and about boxes. So it's just that little component. So when we click on it, we want it to be highlighted, and anything we are not on, we don't want it to be highlighted. So the more complex the component gets, the more you'll see the difference between the APIs. For instance, in Cypress, we have access to jQuery, right? So we can just say, hey, I want to iterate through these selectors. I want to click on them. And the thing I click on should have the CSS active link. And I can use the siblings API just to declaratively say, hey, the things I haven't clicked on should not have this active link CSS. And the rest is quite simple. Now we can do the same exact thing on the RTL side, but it's a little more work, right? We have to resort to using it each, which there's also a plugin on the Cypress side that we can use it each, but we don't really need to do that. We can just simply iterate through the array. Then it's kind of harder to filter out the routes that I have not selected. So I had to resort to using lots of JS inline feedback and wrestle it for a while to get this to work. But the point is, the more complex the component, the more API difference you'll be seeing. But it's totally possible to do the same thing in RTL too. The other point I want to make is on one side, you have the HTML that's being rendered. And then on the other side, you are seeing the DOM, right? So this is an example of a defect I had during development. If I paid lots of attention to it, I could realize that I have this rogue class here that is kind of making everything highlighted all the time. So that's why I wanted to write a failing test that would find that issue. It's much more clear to us what's wrong with our application if we can see into it, right? And you'll see this theme, the difference in many, many places. And the harder, the more complex the component gets, the nicer the UI feedback is going to be. Now, there are a few more examples, and I took these from Epic React course by Ken Dodds. So there are about a dozen over here, and later on you can click on these and compare these one-on-one, but I picked the top 3 highlights. So start with a simple one. This is just a simple Redux. The way we are mounting, and on the left side, we have SciCT, on the right side, we have RTL. The way we are rendering or mounting is exactly the same. I've been wrapping it in a provider and we're passing in the store. That's exactly the same between the two tools. And here we are having a custom store. We're passing in that custom store that we're defining the state for, and the code is like one-on-one compatible, right? So simple components will always translate one-on-one. Here is another example. So we were talking a lot about accessibility as an accessibility example. On one side, we are using Cypress X. On the other side, we're using just X. So they have different ways of injecting it and checking it. On the RTL side, it's kind of different, right? We're making an assignment and destructuring the container out of there, and it has a certain style. It's more obvious when you want to check filtered violations. So the real thing we care about is this included impacts, right? And I'm not so fond of the variable here. Like I would have to look at the API to see what it's doing, but it's a little more complex on the RTL side, right? Most likely, if I had to use this, I would probably make a helper function where the only thing that I want to care about is these values that I want to filter out. It's a comparison between the plugins. For geolocation, I thought this was interesting because it's a question came up about it, thankfully, funny way. And on the component testing side, right, you're stubbing window navigator geolocation. We're stubbing out the get current position method, and we are calling the zeroth argument with fake position object, right? To do the same thing on the RTL side, we have to use just FN, which is very similar to size stub, but then we have to build on top of that with mock implementation, and we have to resolve it with a promise, a callback, and the argument. So this is the exact same thing over there. But there's some additional details we have to know about when we're using RTL. You have to utilize this utility, which is capable of resolving or rejecting a promise on the fly. We need that because we need, after rendering the component, we have to act upon it. We have to wait for a custom promise to resolve, and only then we can make those assertions. On the Cypress CT side, once we mount it, those are kind of automatically taken care of. You don't have to worry about those details. So that's a good set of examples that you can take a look at later. We cover 6, some from an application, some from a la carte examples from Ken Dodds. So let's start talking about sign-on versus jest, some of the low-level spying and mocking capabilities. So SciSpy object and method is very similar to just spy on object and method. We are very familiar with the camel case versus dot syntax between the tools. Something to have been called and times is quite easily translatable between the tools. Expecting some matchers, that's also easy to understand, and this is how we do it as sign-on. Custom matchers are slightly different. So let's say we have this calculator function, we're calling it with an even number and an odd number, and we have these custom functions, right? With sign-on, it's very easy. We can just destructure a match out of sign-on and move on with that. It's possible to do the same thing with RTL, but it takes a little bit of work extending the expect. And the assertion is a nice one-liner. The first argument should match even. The second argument should match odd. On the RTL side, we have to know how it is working internally. That's a two-dimensional array, and we have to make separate assertions. For asynchronous testing, this is the only example that you'll see Cypress has a little more code, but they work quite differently, right? So we're spying on a promise that's doing a calculator method. And on the left side, we can just one by one call it, right? The first time we call it, the result should equal 9. Second time with 1 and 90, the result should call 91, and like that. On the other side, we have to gather all the promises first, and we have to utilize promise all. And that's the only way we can be doing that here. And we can build on top of that, right? One by one, just the first call should have been called with 4 and 5. So we can make an assertion on that, 1 and 90. But just we have to use an nth call with utility, right? And we have to enter the nth number over there. So those are similar. But at the end, using promise all makes asserting the final result easier. With Cypress, we have to do a little bit of work to assert the final result of all these calls together. We've covered spying. Now let's look at stubbing. So we have size stub, which is one-on-one equal to just fn. Size stub object and method, very similar to size spy. With jest, in a slightly different manner, we use spy on, and then I'm sure everyone that's used RTL or jest is an expert on mock implementation. That is how we do the same thing over there. I am usually confused with mock return value, like when do I use mock implementation versus when do I use mock return value in jest? But when I think about from the sign-on perspective, if, oh, this just returns a stub, just returns something, then it makes total sense to me. So these translate one-on-one pretty nicely. More examples. So it's a stub with argument bar that returns true, very declarative, you know exactly what it's doing. To do the same thing, we have to do a bit of work, right? We have to yield the callback as an argument, check if that argument is equal to something, and then make it return something. So very imperative implementation over here. Resolving a promise is nicely comparable. Again, more declarative versus imperative. And rejecting a promise is kind of in a similar fashion between the two tools. You'll see many examples of Cypress and sign-on versus jest over in this repository. These two files are one-on-one comparisons. Many examples of restoring the original method after stubbing, call through, matchers, calling the original method from the stub, controlling the time with cyclock versus jest fake timers, which is the equivalent over on that side. Generally, the theme is declarative convenience versus imperative possibilities. Always possible to do the same thing, but it's more declarative on one side versus more imperative on the other side. So we covered low-level spies. Now let's check out the network spies. This goes aligned with the message that was in the previous presentation about not testing the implementation details. So if you've also been through Epic React by Kent Dodds, he will recommend to mock the code at network level as away from the component as possible. When we do this, you don't have to worry about the implementation details. I have some examples of this in the CCTDD book. There are 3 sections between heroes, villains, and one more section. One of them passes state via props. One of them uses context API. One of them uses Ramda. The implementation is completely different between the 3, but the tests are exactly the same. We don't have to change anything. At extent, what we do is mostly we do site intercepts or mock the network. We have 3 custom mounts, and between those two, 90% of the time, we don't have to mock anything at code level. Most of the time, you'll see things like mocking feature flags at code level, but very rare that we mock other things. Size CT versus Cypress intercept versus mock service worker syntax. Let's compare that. So you may be familiar with site intercept. Basically, anything that's going out the hero's route will be stopped with a 400 status code. You can do the same thing with mock service worker. However, there's some boilerplate, right? We have to define the handlers. So this is the URL portion of it, and this is the portion that is returning a certain response. We have to set up the server with those handlers. We have to listen to it, and at the end, we have to clean up. So these we can make a little nicely isolated if you're using test hooks in groups of it blocks, right? But let's say we have an example, and let's say the delete stubbing of the network is only relevant to this it block, right? We don't really have that capability with MSW because then we wouldn't be able to take advantage of these hooks. So we have to declare all the handlers in the beginning, and we can't really change it on the fly. So on the left side, for instance, we could add another if block that stubs out the network a little differently if we're deleting something. But to be able to do the same thing, like we can't override delete over here, right? We would need another describe block. We would have to repeat the boilerplate, right? That's why, in my opinion, MSW is great because it doesn't. There's not much of an alternative. It unlocks a whole different paradigm of not stubbing details, not testing implementation details, but stubbing things at network level. But with Cypress Intercept, it's much easier to use, declarative, less code, succinct, and that ends up in quite a bit of a difference between the RTL and MSW version of a component versus SciCT versus the Cypress Intercept. And this kind of a difference was one of the main attractions at Extend, right? When we wrote the same test with Enzyme and the way we've been mocking all the details at the lower level versus using Cypress Component Testing with custom mounts and Cypress Intercept, the tests were half as short, quarter as short. People were mind blown how much you could do with less work. So that was a huge buy-in for our engineers at Extend. So we talked about the low-level spies, network spies. We compared some examples. Let's come to the more exciting part. There's a live demo of the developer experience. And the only way to really do this is with a live demo. Gleb reviewed my blog and he recorded a video of these things. So I thought it'd be very cool to try to replicate the same thing and sharing with you the developer experience. So we'll start with the header bar brand component and we will introduce a failure. So here's the component on the left side, right? And it has these 3 spans, and we'll just change this off to on, right? And we'll see how RTL or just responds to this change. So the test fails. You can see the second test failed. It has the DOM being rendered over here. It says it failed on line 31. We can see that right here. Now, if you can associate this tour of heroes saying, okay, one of them didn't get the right text, we can associate that with the HTML render. Oh, it says on here, but we were expecting off. Then, okay, that's the defect, right? That is the developer experience. When it's simple, it's not very painful. When the HTML is short, we don't have to try so hard. On the Cypress side, if we run the same test, right? Let's just run it over. It's trying to find the span width of. I don't know if I can. Okay, here we go. Perfect. So we time travel through it, right? The span width tour is being selected and it's looking for another span width off. We don't see it. Immediately realize, yo, it says on here. So what's the problem, right? It's kind of obvious. But if that's not enough, we can go to the console and focus in on what that command was applied to, and we can immediately see in the DOM right there that, oh, it says on over here. And if that's not enough, we can just go ahead and inspect the entire DOM as it was rendered, and you can also see the problem over there, right? So this is an example of a easy to use component. So let's close this one and then go to the input detail component. I'm going to have to wait for this to run and filter out input detail, show more, input detail, and I will let this run in a passing way, and I'll just demo the component so we have an idea. Input detail, close this console. So this is just a text field, and we can't write into it. In this case, it's the second test, but in the first test, it is writable, so I can just click on it and kind of ad hoc the component, right? So we are testing that, the more we click in it, the more a call is being made. So let's take a look at the test real quick. So here's the test, right? And all we're going to do here is this onChange property that we are stubbing out with just FN or SciStub. We're going to replicate an asynchronous process. So we kind of run into this situation almost all the time in any meaningful test that we are trying to do something with the component. So imagine this is kind of a network call or something that's causing the DOM to be asynchronous. It's just not synchronous anymore. So let's comment this out. We'll have to use TS expect error on here because you're just changing that with a set timeout of 3 seconds. So the change event will happen with a 3-second delay, right? So we just change that, and we'll see that the test will fail on line 28 right here. So the input field changed, but checking on its on change, it was synchronous, right? We have to make the test better. We have to make it a little more asynchronous to make that work. So to make that happen, to make asynchronous assertions, we use the wait for utility in RTL, but I'm afraid that's not going to be enough in this case. Then we'll have to kind of use this hard wait also to make the test pass. So this one-liner will have to be replaced by this multi-liner, being aware of an asynchronous assertion. On the Cypress side, we didn't have to change anything, guys, because of the retry capability of Cypress that's built in. So it's retrying for 5 seconds, as you see here, to get that working, and voila, it works, right? We don't have to change any test code. And this is the primary reason you'll find that Cypress component testing is more stable than RTL in CI because of this retry capability for the tests that are trying to do things meaningful. Before then, our tests weren't that meaningful, right? They were just static, does it render this kind of data? But it wasn't really like clicking around things, using it as a real user. Those get very flaky with RTL, but not so. We don't have to do any maintenance for CI/CD in that kind of a case. So this was a nice example of asynchronous processes. So I will revert that change real quick. The final example, we try to remember this one. So later on, if you take a look at the presentation, we'll have a GIF version of the demo. The final one, testing in the dark versus testing with lights on. So seemingly innocent issue over here. And then I will close this guy, and we will use the hero component. So we'll have to let this run and then change WP heroes test. We'll have it pass. And I will just run the test in Cypress Component Test to communicate what it's really about. Heroes. So in this test, what we're worried about is the 200 flows and going through an error case. So we are deleting, let me just time travel through it right here. So here we select the first hero. First we're loading, we're making sure the spin is there. We are loading a hero, we have the modal, all right. And then at the modal, we're clicking the yes button right here. First we do cancel, we have the model's visible. We get the button, we click on yes. Right after we click yes, we have stopped the network with a 500. So we're trying to simulate an error case over here. We wait for that network request. And then after that, we check that the model is gone. And finally, we check that the error component is rendering in case of an error. And so this is the test. Now, let's introduce an obscure but seemingly innocent bug here. Like, let's say there's something wrong with our hook. And in this case, our hook is use delete entity. It's using React query to delete a hero. So let's say something internally went wrong here, right? I'm going to comment out this line, which is handling the deletion at the modal. I'm just going to save it. I'm going to let both tests run. So first, let's look at the RTL, right? Let's look at the RTL test. And what we'll do is we'll have CI/CD versus RTL open at the same time. So let's have CI/CD on the right and RTL on the left. And the part that we're interested is this test, right? We are stubbing out delete. And in this test, if you remember, we're using mock service worker. We had to do things in the beginning to mock out a 500 response. And here we are clicking button yes on the model. We're checking that the model's gone. And then we're checking that the error is visible. Same exact test over here with the addition of waiting for the network. So we're not capable of doing this on MSW side. Last time I checked, there were requests, but we're not able to do that at the moment. So the test fails, and then we scroll through it, right? We can see that it failed on 93. So if we ran it again, commenting out on 93, that would totally work, right? But so we know that error component is not rendering, and we have the whole DOM being rendered here, and we kind of confused, say, why is the DOM being rendered? Why isn't the error component being rendered? We don't really have a clue. Is there something wrong with the error component? Because the error component is handled in a higher level in our application. We're wrapping it with error boundary. So we don't really have too much to go out on. We're literally in the dark trying to find out what happened to our application. We don't have enough observability into it. Let's look at the Cypress test. So it is running, right? The whole thing went through, and it's waiting for the delete message to go out of our application. So we do the click, right? We do the yes, and after the model went out, we clicked on it, but the network didn't happen. So immediately we can tell, hey, what is supposed to cause the delete? Well, it's the hook that's supposed to cause the delete, right? So then we deduce that, hey, maybe there's something wrong with the hook, and then we can move on from there. We can go to the hook, the custom hook, and then we can diagnose it there. So that is a way to compare the developer experience between the tools. All right, so what does that all mean? What does that all mean? We covered all these examples, Cypress component testing versus RTL. We covered 6 examples. We covered sign-on versus just network stubbing capabilities. We covered developer experience with 3 examples. In summary, there are many similarities between Cypress component testing and RTL. If we know React testing library and some Cypress end-to-end, we will be very comfortable with Cypress component testing. It's kind of similar to knowing German and learning English, because German is a lot more complex than English, but if you know German, it's so much easier to learn English, right, for German speakers. Usually you'll find this thing between that. So on the Cypress side, it's going to be declarative convenience versus on the RTL side, it's going to be imperative possibility. It's possible to do the same thing, but it will most of the time take a little more work, a little more internal knowledge of what's going on. But I think the key differentiator is the developer experience. On one side, you have the real browser. On the other side, you have HTML. On one side, you have full observability of the application. On the other side, you're working in the dark. And this makes the entire difference when you're iterating in your engineering processes. It just makes everything so much faster. I'll finish with all the links and references I know about component testing. The whole presentation was based on this blog post. I have a book on Cypress component test-driven design where you'll find so many examples of CT and RTL side by side. The book is about an application. There's a Vite version of it here and a fake React app version of it. This repository contains more than 400 Cypress component test examples. This repository about sign-on versus jest in the same repo. You can compare those one-on-one. And here are 2 extra applications, one from React Hooks and Action book, includes Cypress end-to-end and component testing, lots of examples from testing launch darkly, feature flags in a React application. This other one, Bookshelf, is from Kent Duss. So it's his Epic React course, and I added some Cypress end-to-end and component testing into it so you can see those side by side. That's everything I wanted to share, guys.
Thank you very much. That was terrific. I really liked getting into the weeds on some of the sort of practical pieces of not just like at a high level, what is the impact and the concepts behind component testing, but like, what does it actually change for you? If you're using React testing library now, do you just get the browser in Cypress and it's that one change? This whole developer experience demo was fantastic, really appreciated. So I have a couple of questions for you before we move into the kind of overall roundtable discussion. But you got in there and you answered a lot of these already in the text in the Q&A. So I had a couple of things that stuck out. One was like you were testing the 500 with the network. And within like just your experience, how are you or the teams you work with deciding like, well, how many error responses do we want to test from the server? Do we care if it says I'm a teapot? Do we care if it says like 200 or, you know, how often do you find yourself deciding, oh, this is worth testing this error? Should we test errors for every API request? What do you think?
Our developers are surprisingly very aware of this, right? That makes me very glad. And they're very comprehensive at a lower level to cover these scenarios. In fact, they were doing it even before Cypress. trying to cover these error cases. So if the component has a pathway towards an error, they will make sure to cover it. And I find it that it is easier to cover these error cases. It doesn't matter if you're doing component testing or serverless testing. Right? It's always easier to mock out error cases at a lower level. And that's what we do at Extend. So they do cover all the possibilities of the component, usually 400, 500. So is it a 200 or is it a non-200, right? Usually that's easy as that. And yeah, they even go a step further, testing all the toast. They love the toast stuff.
Very cool.
So that's what we do, yeah.
Okay, great. And then you mentioned Enzyme as well. I think this might be relevant to React developers on the call or people who are not developers, but their teams use React. So you're motivated to migrate away from Enzyme so you can upgrade your version of React so you can use new React features. How much is that like, I guess, how's that decision driving your team's choices about when to test or how fast to migrate? What is attractive about new versions of React that people want to use that Enzyme is kind of blocking them?
Between React 16 and 18, there are a few key updates, but the ones we are more interested in is concurrency and user experience, right? So, sometimes we are overfetching with our application and that ends up being a slower user experience. React 18 would give us the possibility to make that seamless, right? And also we're considering Next.js in certain cases, but Enzyme is a blocker on that too, right? It's not going to work. And we just have to migrate out of it. So the decision was, hey, do we migrate to RTL or CyCT? I didn't really push component testing anywhere. Right? And one application took off with RTL, and that's perfectly fine. They are interested in Cypress Component Testing now. So some of the new stuff they're using Cypress Component Test for because they love the observability of the component, right? That harder to reach deeper components, not having to serve the entire application there. So we ran into a case, for instance, this one component had a ambitious hook, and there are all these like rogue network requests going out of it. Try to decipher where that's coming from in a full application. It just slows down your application. You have no clue because all these components may be causing this. But so much easier to see that into a component. And forget about RTL, right? You're never going to see something like that in RTL. I also like the experience of seeing things through development as they're changing the component versus having to write tests for it all the way at the end, because that's the only way they see their component, right? First, they got to get working on that application, and then maybe they'll write the unit test for it. But with CyCT, you do this upfront as it is open, and you get immediate feedback. And that quality of the feedback is what accelerates the engineering experience.
Okay, cool. Thank you so much for those answers. I'm going to share my screen again briefly just to get that resources link back up and get us ready for the next part of this.